Yeah, this is good.
Anil sir?
Yes, I'm ready.
Start madana sir.
Oh, definitely. Why not? Sorry, it's 7:05.
Okay, okay. We'll start now.
Yes.
Yes, yes, sir.
Sir, Agadre, I'll do the
Yes, sir. Yes, sir.
welcome and hand it over to you. Kindly request you to introduce today's resource
Yes,
person,
sir.
and
Yes,
then
sir.
just inform our participants how to get the
Yes, sir.
the certificates. Download.
Yes, yes, sir. Yes,
Okay, sir. Yes.
yes, sir.
Okay, I'm ready.
Yes, sir.
It started.
Yes, sir.
Okay. Good evening, all. Warm welcome to all the participants of this particular webinar. And as a chairman of Indian Concrete Institute, Mangalore Center, I take this privilege to this second webinar session in the past 3 months. And I first of all welcome the resource person for the day, Dr. Venkata Dilip Kumar Pasupuleti.
Thank you, sir.
Yeah, sir, most welcome. And we are going to listen to your enlightening words and the new infos. I think we need to upgrade ourselves. And after listening to you, I think definitely we'll upgrade much better than how it used to be earlier. So once again, welcome you, sir. And at the same time, brief history about Indian Concrete Institute Mangalore Center. Though it is inaugurated about 7 to 8 years or almost 10 years back, there were some ups and downs. And for the second time, we have revived Mangalore Center, and we are going ahead with full energy. And definitely when organizations who are into the concrete industry like Qcrete, Readymix, and the technocrats like Kaushik sir with us, so we don't have to bother much. And at present we have very good leadership based in Bangalore. That is Sudarshan sir from past, that is Civil Aid. Now he runs his own consultancy firm. He is our VP South, and we have many more leaders of this for the South India. And today, at this same time, I would like to welcome all the participants and members of Indian Concrete Institute Mangalore Center to this second enlightening webinar series from Qcrete and Indian Concrete Institute Mangalore Center. Thank you, and over to Kaushika sir.
Good evening. On behalf of Qcrete Readymix India Private Limited, I believe it is my honor to introduce our today's speaker, Dr. Venkat Dilip Kumar Pasupuleti. This is his third lecture, in fact, on our platform, and I will have a brief introduction of him. Dr. Dilip Garu has finished BE Civil Engineering in Osmania University, Hyderabad. He did MTech in Computer-Aided Structural Engineering in IIIT Hyderabad. Then he went on to finish PhD in structural engineering in IIIT Hyderabad in 2016. He has been currently working as associate professor, Mahindra University, Centralized School of Engineering, Hyderabad. Before that one, he was assistant professor in Anurag Group of Institution, Hyderabad. Then he was also visiting faculty earlier in Vidya Jyoti Institute of Technology, Hyderabad, 2014 to 2016. He was a lecturer in IIIT Hyderabad, 2011 to 2014. And he started his career, you can say, in IIIT Hyderabad in August 2007 to August 2011. And he has been involved in teaching students. At present, he has founded the Center for Sustainable Infrastructure and Systems, CSIS, with CS faculty in Mahindra University, and he is guiding 40 UG students in CSIS and has presented his research work at various international conferences and won several best paper awards. He is currently 30 students at least are working on structural health assessment and monitoring, which is one of the leading live projects of CSIS. And he has a very vast list of publications. And if we start reading about his publications, we will consume maximum time, and probably we will not have time for his lecture. So I will just say that Dilip Garu, as I know for last 4 years, is a wonderful human being above all, and always interested to guide students and help students in any best possible manner that he can. And he has been, I can say, a pioneer in the field that he has chosen, that is structural health monitoring, and he has been contributing significantly in this field. With this short introduction, we, on behalf of Qcrete, we once again welcome Dr. Dilip Garu. Over to you, sir.
So thank you so much for inviting. First of all, I would like to thank Anil Balga sir for inviting from ICA, and Kaushika sir for inviting from Qcrete. I'm very happy that I got this opportunity to share our research. So just before, can I share my screen?
Please, sir.
Yes, I think if my so if my slides and if my voice is audible, I think I'll go ahead with the presentation.
Yes, sir. Perfect. Please go ahead.
So,
okay.
So is it possible by any chance to make it full screen, or is it the best that we can do?
I think I have kept the full screen only.
Yeah. Okay. Okay, sir.
Okay.
Okay.
So very good evening all. Again, once again, I thank ICI Mangalore chapter and also Qcrete Readymix India Private Limited for organizing this webinar. And this is something which is happening all around the world, and this is latest. So I have told that we would be giving on this. Even this is also we've been working on from past few years, where we had a lot of challenges in last decade, and then we have to adopt for unmanned aerial vehicles and AI. So this is so just before I start, I would like to wish you a very happy new year. It's delayed by almost 22 days, but just want to say that it's a fresh start, and I'm sure you all have endless possibilities, and I'm sure your dreams come true in the year 2026. So again, special thanks to Indian Railways, NHI, and MORTH, because if we would not have given opportunity by them in assessing the bridges, then I don't think we would have reached this far. So we all have a story to tell, And I would like to tell our journey of with the bridges from last almost like 12 to 15 years. So, oh, just a minute. Okay. So special thanks to Kyoto University. 2024, we spent some time. We have some collaboration with the Kyoto University where we are still improving, especially in structural health assessment and monitoring using advanced technologies, out of which one is this vision-based assessment. And we always had an opportunity to visit one of the iconic structures in the world like this, which has been the longest suspension bridge and most probably the first longest suspension bridge built in the world. So we were always curious to know how do they assess such kind of a bridges. Manually, it will be challenging. Same way we had some challenges in India as well. Now it is very important for any university or a research center to have a collaboration with the industry. And in that scenario, we were also very fortunate that we had very good collaboration with certain number of companies where we had real-time problems. And as a research center, we have took up those real-time problems, and then we tried to solve in two ways. One is manual and one is with technology. So, and especially we are more into the bridges, and someday we would like to reach excellence in understanding the bridges. So we were trying to bridge, and this has started from the year 2017. And the current research team, I'm also fortunate today that I have requested my 2 research students to be part of this presentation, and I also wanted them to talk for a minute at the end of the presentation. Mr. Mohammad Mustafa Ahmed, who was actually working on AI, and Revant Sagar, who was working on drones. We have Ms. Datri, she left to US for doing masters, and we have Ritvik, who is also working on vision-based. But this was all because of collaboration. I am myself a civil structural engineer, and it could not have happened without the help support of Dr. Profula, who is from computer science and artificial intelligence background. So this is the team. The whole presentation actually is the work which was done by this team. Note, I have presented or we are trying to present the work which we have did, and some images I have taken from internet. I may not have given source, but end of the presentation I'll give you the source. That is only to make presentation interactive. But as I said, there is an effort of team and a lot of people thinking on that. And a lot of industry's contribution is also there in this to reach this stage. Outline, I'll just give you the background and what motivated us to do the automation and where we have started, how do we entered into the real structures, how do we made automation, and where are we heading to. So this is what the outline of today's presentation is. So as a teacher, I always tell the basic education, like what did we learn in civil engineering? Or we all have dreams to become a great civil engineer or in fact any engineer. And then we wanted to be part of any of very iconic or very large structures from the foundation to the completion of the project in a sustainable way. So what we did learn during our education is planning, analysis, design, and construction or execution. This is something which we all have learned in all engineering colleges in India or abroad. And then we've been doing very good. There might be some problems, but yes, this is what we were all taught. But when we see certain kind of scenarios like this, then how do we answer? How do we, without any kind of a basic understanding, how do we address some kind of a problems like this? How much is it affected or how much is it damaged? With what quantity it has been damaged, or what is the amount by which load carrying capacity is reduced? How do we understand such kind of a structures is something which was largely missing in the last decade. So what was missing is trying to be filled by today's education. So civil engineering is not only about a building, but it is also about civilization and also maintenance. So currently, as the structures are aging, we need doctors. So we have stepped down to those shoes where we would like to assess, feel, and understand the structure. The introduction part as bridges, Indian government has been building a lot of iconic structures, including the research Chenab bridge as well. And we have very high altitudes, different temperatures, long span bridges. A lot of bridges have been built in India. Not only bridges, but also infrastructure as in buildings as well. Government is trying to invest lakhs of crores on building infrastructure because that actually is one of the dimensions to tell a country is developed. While infrastructure is being built, there are a lot of challenges. One is its aging, and also the condition, and also the quality of construction, how this being built or constructed over the years. When we come back, this is one of the bridge which have collapsed in West Bengal under the construction. Was during construction and it has failed, one of the major fatal. And the second, this is in Himachal Pradesh. Suddenly the bridge have failed after 15 years of construction. And third, this is almost 99-year-old and was tested by civil engineers and was given certificate that the current traffic can be allowed. And after giving certification, this was washed away with the floods, because engineers, when they tested for the live and dead loads, but not for the flood loads. And similarly, there are multiple other kinds of accidents which are happening during construction. And this is Mahindra, as I said, lost 30 people during that demolition collapse of the bridge, which was washed away due to flood. And this is in 2023. Sorry. This is in 2023 when there was a flood in eastern part of the country. Almost hundreds of minor culvert bridges have actually washed away. And we have visited very recently, we could still see the effect of washed away roads and bridges still existing at that part of the country. And you can see, and you can actually see the link, and you will find more reasons or more results or more details of the kind of structures and roads which have got washed away. So bridges have been one of the most important, as they are very costly. Every part, nook and corner of the country, they become very vital for any country's travel or even export and import as well. Now, CRRI, Center for Road Research Institute, have taken up a special study, and they have tried to understand and the average age of failure of these bridges. So from the year 1977 to 2017, they found that 2,130 bridges have failed, and the average age of bridge was found to be 34.5. We all know, as a designers and engineers, that all the bridges are generally designed for 100 years. But then failing at 34 or 35 years is actually, we are losing 65% of its age, which was one of the most surprising statistics even for the Indian government. So of course, we know bridges cannot last forever, as they are subjected to different kinds of loads, and aging is a natural, it's a natural process, and degradation would happen. Either it is a man-made or it is a nature-made. There are a lot of parameters which are affecting the age of the bridge. But if they are constructed for 100 years, how can we stop any sudden kind of a damages, or how do we rank this? It's not only in India. UK has also conducted several random survey on those bridges, and it is said that they designed for 120 years. Even they have found that their bridges are collapsing much ahead of the design life. It's not only in India and UK, but US, Russia, China, and other parts of countries of Asia and Europe as also have found similar kinds of problems. But in India, the average age is considered or is found to be very less when compared to all other countries. Now, there is one case which was a study which was done in multiple countries. The study was very simple. A bridge was given to 10 different engineers of the country, or the famous engineers, so-called country, and they were asked to rate a bridge. And all 10 different engineers have started to rate the bridge. As one engineer said, it is good. One engineer said there might be some problem. And another engineer said it needs minor repair. And another engineer has said that there was total fault with the bridge. So the question was, even for the Indian government, was how did it so happen that the same bridge had 10 different readings by different engineers? So when inspection is subjective, of course, it depends on the experience of the person, understanding of the bridges, understanding of materials, there are a lot of subjects. So when inspection is subjective, the same bridge tells different stories to different engineers. And again, one bridge, but it's a different non-uniform rating. So this was also one of our motivation. How can we rate the bridge based on the visual inspection? Can we make it uniform? This is one of our first objective. And as that has been known, much before that, Indian government has started something called Indian Bridge Management System. And Indian Bridge Management System is all about trying to have all the data about all the bridges in India at one platform. So it is about regular inspection, assessment, repair, any kind of what kind of bridge, what kind of material, what is the span, every detail. It's like an Aadhaar card of a person is like they are trying to give Aadhaar card to every bridge in India. Now, when this was done between 2010 and 2020, you can find the statistics in MORTH or Indian Railways website. So you know approximately, this is from directly from website, but I'll just skip. Approximately till today, 1.92 lakh bridges have been inventorized. All this data has been kept in that Indian Bridge Management System. But what is the main objective of Indian Bridge Management System? After having all this data online, they wanted to see the statistics, or they would like to know what are the bridges which have to be repaired immediately, which have to be stopped immediately, and so on and so forth. But since the inspection of these bridges have taken from 2010 to 2020, almost 7 or 8, there it's a 10-year span, a decade of span, updating. So once this was done, they can see, you can see here all this data about the bridge immediate inspection essential to decide reconstruction, like 4,000. But this software which was built on this was not trying to get all the information about all the bridges, as the information updated on this server was not uniform. And again, the second thing is, how do we update the data automatically? Every 3 years or 4 years, have people going into every bridge and updating that data would be very challenging. So one of the challenge was data and upload. So how do we do that? So that was as challenging. And now Indian government has come up with a new thing, which is called Bridge Health Monitoring System, DHMS, where they are trying to infuse sensors, IoT, and artificial intelligence. And now this presentation would like to focus more on AI, especially the assessment of bridges based on only visual inspection. Even though we have did a lot of other bridges based on sensors, IoT, and we have come up with our own code of software where we analyze the even vibration data as well. But then this presentation is limited to, we are limiting ourselves to implementation of AI. Sorry. And then I will not really try to talk about what exactly AI is all about, but how did we do this? So in the year 2015, 16, and 17, we started inspecting bridges. I think till now, our research center, we have actually inspected more than bridges in last decade. And this is from 2017 to 2019, we did 700 bridges assessment in every possible detail, like length, heights, girders, structural damages, non-structural damages, scouring everything. And these are few images while we have visited a couple of sites during our inspection between 2015 and 17. And some of these images were very surprising to us, and there were more deteriorated bridges as well. But again, the challenge is how do we rate them? And you can see here it is a non-structural elements. We have a scouring problem, and then we have a lot of spalling problem, corrosion problem, and we have a masonry and concrete bridges. A lot of different mixed material bridges were also there. Now, when we have tried to visit this, some of the bridges, what we found was roads were absolutely very good on the top, and when we go to the bottom, and we could see the complete ductility has actually highly corroded and broken. And you can see the spalling, and you can see the condition as well. And there were some foundations which were actually built on the clay, and they were also sliding on it. And expansion joints were another part of these inspections. But for this, we have to take a very good DSLR cameras, zoom in, zoom out, And then sometimes we had to get into the water, mud, everything. We had our own challenges. And these were other railway bridges, one or two, just for the images to show. And then we had to take ladders, and then we have to get onto the top and get onto the plate girder. We have to take images, and we have to see the corrosion. We have to take the hammer and hit the rods, and we've seen the completely corroded on this one. And you can see the kind of corrosion, and we've seen, but it was very difficult for us to measure all these damages at such kind of locations. And you can see the severity of the damages as well. You can see in this image the highly corrosion, and then completely rods were completely, they became brittle. And here the boundary condition was highly corroded, and it was almost losing its load carrying capacity. Now that's just because of the drain. This is for the drain pipes. Anyway, on the top, that bridge was absolutely very good. Traffic was going at 80, 90, and hundreds, but below of the bridge, it was completely corroded. It was becoming brittle. Now, apart from all those, we recently did major structures, especially bridges of around 2.4 kilometer, 2.5 kilometer. We have road cum rail bridges, and you know, it was very challenging to reach certain locations. And you know, these are all images I took from internet, just to tell you that there are a lot of difficulties and challenges. I am not showing all the images, but I'll show you one or two where our team was actually trying to get some geometrical details, and they were trying to have a sensor sensor on the couple of elements of a structure. And you could see the kind of frisk for laser meter or anything to get, especially when we are interested to convert the as existing bridge to the numerical model or a digital twin. To get all the measurements is always a challenge. So then we started this limitation. We have known that assessing the bridge is always challenge. Sorry. And there are, of course, there is always a risk, and this risk is almost there for every bridge. And sometimes we have to stop the traffic, and then sometimes we have cost is involved. Sometimes so there was a lot of flood water and everything. With these limitations, we have known that, and all these bridges have also taken a lot of time. So we know that manual inspections are slow, they are very subjective, risky, and of course they cannot be scalable. Now another thing is, within our team, people who have assessed different bridges, even the reports which we got were also very different. So then we thought, why not we start some methodology where we can inspect our bridges frequently, much faster, and it should also be safe for our team. Then we started getting into this vision-based analysis. First, we started with simple cameras, DSLR, LiDAR, thermal. All this can be used with drones. I have kept unmanned aerial vehicles just because UAV will just help us to go to the location. But there are different tools like LiDAR, thermal, and cameras, DSLR cameras, to get the precision or the information what we really require. So then we started photogrammetry. And photogrammetry is something that you take images of any object from multiple dimensions, and then we stitch them to make it a 3D model. And generally, if our camera is very good, and then when we make it a 3D detail, then it is the accuracy what we found is very good, and it is safe. And the amount of time for doing such kind of inspection with drones is also almost like 70 or 80% much lesser than the human manual inspections. And once with manual inspection, again, if you want to recheck the data, it is always challenging. But with these drones and images and 3D reconstruction, we can visit the structure again and again when we have this. So when we started data acquisition for photogrammetry, we started with a simple smartphone, and we started on a small research laboratory. We had a scaled model of FOB. We did that. And smartphone and DSLR cameras. A DSLR camera actually if it is used with the drone, then even 0.01 mm crack almost negligible cracks can also be measured, it can also be seen. And RGB depth camera and also thermal images can also be taken to understand various other parameters of the structure. And when we have UAVs, specifically, I'm not talking about any UAV. When we have UAVs, we can have a manual UAV where you can actually control the drone with your remote, and you can actually see what your drone is seeing. Or the second one is you can actually give the path and the drone can take the path. Or the third one, a drone can autonomously inspect by itself. Okay, we have not reached till here yet. So we are working currently on automated paths where a drone can take that path and can actually inspect the bridge and get us all the images. Now, when we are trying to do the photogrammetry, one of the most important thing is we just have to see, since we are trying to build a 3D model of that, we just have to ensure that there is no movement near the bridge where we are trying to reconstruct. And the second, most of the people would ask about the timing about taking the images. We cannot, it's not that easy if you take early morning or late evening or mid-afternoon. Basically, images have to be taken in the same amount of time, basically from 9 to 11 or early morning from 6 to 7. So that there is a not contrast is not there on images because of the lightning and any other things. So then this is one of our first experiment, which was done by our research students. So they've taken with cell phone. This was completely reconstructed by the images which were taken by a simple cell phone, and we were able to see almost every detail of nut bolt of this once it was completely reconstructed with 3D. And then once we started with our model, then we thought, why not we just go and actually have do a real bridge. But the one thing is important is the accuracy of this 3D reconstruction, whatever we are trying to present here. In our case, it was actually around 80 or little higher than 80% of overlap has to be there, so that every detail of what we are trying to understand about the bridge is actually used for the 3D reconstruction. And whatever the red color dotted line you are seeing is actually the path taken by the UAV. And from there, which this is the actual 3D reconstructed model. And this is how generally this is being done. If anybody is from computer science, of course, they would know that the photography is the first part, and second, when we actually use the software or the code, all the images are converted into a point cloud, and then the surface is generated, like what we see here, a 3D model. Now, this is the model of that, but you have to know when we get from the visual inspection, we have to understand that it is only the surface, not the internal part of the bridge. This we would like to tell you, but these are not solid elements, but we'll only get the structural or we'll only get the textural part. But if you see, you are able to get all the pipe details, stone details, tank details, road details, and everything with very, very, very higher quality. And then once that was done, then we thought, why not we do for a complete bridge. And then we have taken UAV to one of the masonry bridge, concrete bridge, and steel bridge. And we have given the path, and you could see that. Now, there is also one more thing here. When a drone is used, either we can take pictures or you can take video. But when you take a video, almost the drone, I think the speed of the drone is almost like, I think it is much lesser than 1 meter for a few seconds, or it goes very slow, so that when we have these images, those images are with a higher quality. When you convert your video into image, it has to be higher quality. Otherwise, constructing into a 3D model would be very, very challenging. So we use this, and then this actually the software or the tool. When we have this, it uses something called SIFT or SFM, And this is called scale invariant feature transform. I may not be talk much on this right now, but it will also use a simple machine learning algorithm. This is it is something to notice that all the similar points or exact points are actually are mapped. So, and it will also take care of the image from the different perspectives, because the image might not be taken from the structure. Sometimes a drone might not maintain the same distance from the bridge to its place. So sometimes you might have a little far or nearer, but yet all these images have to be stuck together without the change in the scale when it is constructed in 3D. So this is structure from motion or SIFT. When these are used, then all those things are maintained, the mapping. And these are just for your information. So we constructed a masonry arch dam, which we have showed which we have showed previously. It has got almost 4,159 images, approximately 4,200 images to reconstruct this model. But when the model was reconstructed, then one thing was sure that even a person can actually count the number of stones in the bridge that as well. And next we did for the complete masonry arch bridge, and then we took around 5,247 images to reconstruct this bridge. Similarly, a steel railway bridge and concrete railway bridge and composite bridges as well. So we work with various number of images, quality of images, and used for 3D reconstruction. Now this is the complete 3D reconstructed model. This is the complete 3D reconstructed model of the masonry bridge. Now once this was 3D reconstructed model is there, now we were also trying to understand that how do we know the damages, or how do we highlight the damages on this. So we get on to the next part of this. And just before that, just want to add that it sometimes seems to be easy, but it really requires a good system. So this is one of the configuration system which we have used, like 64 GB RAM. And then we were also using a special NVIDIA GeForce. And for that, it actually takes almost 2 to 3 days. But this was after figuring it out, a lot of mistakes, trial and errors, a lot of everything. After understanding everything. But before that, I think we spent more than 6 to 7 months only to understand, to reach this quality of the image. And then again, being very fortunate, our team, as I said, Mr. Mustafa and Ahmed, and with the team from KDM, we had an opportunity to visit around 80 masonry bridges in Jhansi, where Indian Railways was trying to for a double lining. So what we did was, during that inspection, we had to get every detail about the bridge. And with the railways, when they wanted to increase the load of the train, or if they wanted to increase the speed of the train, they wanted to make sure that the bridges on which these trains are running are absolutely safe. They didn't want to take any risk. So while we were trying to do the assessment of all these bridges, we figured it out. Of course, for this case, we were trying to tell you about masonry bridge or a concrete bridge, where we have tried to figure it out, and we got all kinds of possible damages which might happen on concrete or masonry bridges. Like here, you can see different damages like crack, vegetation, seepage, water seepage, and water loss. And then, of course, we have a crack of concrete structures. We have cracks, corrosion, spalling, and a lot of other similar kinds of damages which are there in structure. So then started using artificial intelligence. As I said, I'm not trying to teach artificial intelligence, but we would like to talk about how did we use AI. And this is specifically, it is a part of deep learning, where we use convolutional neural networks. And we got a data set of all these images were collected from all the 80 bridges and few more bridges in and around Hyderabad. And then we had to teach computer what kinds of damages are there. We had to highlight all the damages, which is also called annotation. And we had to do the augmentation, because sometimes images might have been taken early morning or late evening, mid-afternoon. Maybe sometimes it's a cloudy sometimes it's rainy, or images might have been taken from different. That is called augmentation. Augmentation, which means we change the images into flip, rotation, saturation. We change the images so that our CNN model actually understands that this is the same thing. And then we've used YOLO V11, and we also asked classification, and also instance segmentation is also being done. And then we tested the data, and we have also got the results as well. So this is the process, and like these are the major damages as said previously. And even that was also one of the bigger challenge. Was it was very difficult for us to take all the images of the bridge, or even during rainy season, it's not that every detail of the bridge can be got. And after the rainy season, you have lots of trees and bushes where it's very difficult to go inside for a human being. And a lot of things where measuring was challenging, so they had to use laser or sometimes tape to get all the information. But any time of all this doing practices currently might lead to minor error as well. Maybe sometimes a greater percentage of error, which might not give us the good results while we are trying to assess the actual bridge. Now, this is the methodology. The most important for any of the computer models when we are trying to convert into data-based analysis is important is data. And second one is the annotation part. So the right part, like you see segmentation, and then we did annotation, augmentation, model training. This is the most important. So how precisely we can draw all the damages and try to teach to the computer is the most important. Improper of that actually could lead to the errors. So the accuracy precision could go down by a drastic margin. So it is very, very important that annotation is done clearly. So most of the time, our team have spent for annotating all the images. I think we worked till almost for masonry, concrete, all the images. We worked on more than 5,000 images and actually annotated different types of damages. Maybe around current data set is more than 8,800 images, which includes concrete, steel, and masonry. So once that is done, and then this is augmentation. So augmentation is the same image as it was previously said. Either you rotate or you in the lightning, and then contrast and other things. And then testing was done. So when testing was done, you could see. So and results which we acquired was, this is the ground truth which were actually annotated, and then it was the model prediction. So what we found, our model prediction is performing well, performing really very well. And then for concrete, the accuracy is very high. Masonry structures, since masonry structures are not many as such and data is not that high, so the accuracy of concrete and masonry comes a little down. And this is the results which we obtained of the model performance for unseen images. For automatically, it has highlighted about the water seepage, about vegetation, about motor loss. You can see all this. And now we're still working on, it can also have a different colored scheme and highlight the different kinds of damages on the bridges as well. Now, once that is done, and again, all these images which were actually have used, YOLO model has been used, and to detect and classify and instance segmentation was done on all the images to understand the damages. And then with the images with all kinds of damages, then were actually used again to use the 3D reconstruction. Now this bridge now has got all the highlighted with all kinds of damages which are regularly seen on the bridge. Now this is what was very important to us. Now, but when we start rating, how do we rate the bridges? So then this is also done for this. And another thing about this is, once that is done, to get the measurements are also very, very high. So from the 3D model, and if you know if LiDAR is used, and then we can get every detail, geometrical detail from the 3D reconstruction. So here we can see that we are able to measure, you have got almost 11.2 meter, and then what we've seen, what we have measured from the site and from the 3D reconstruction, almost the accuracy is 99%. I said if the lidar is very good quality, it's almost you can get almost 100% accurate, or basically from 98 to 100%. Lidar is that accurate. So once the advantage of using UAVs of complete and using this 3D reconstruction will give us as-built diagram of the existing bridge. There are a lot of very old bridges where archive of this diagrams, the geometries are not available. So with this simple methodology which has been used here, can also give us complete geometrical details about any bridge which might not have prior. And as I said, accuracy is also very, very high. Now, once that is done, and then the comparison of these models, the 3D reconstruction of the model, one without damage and one with the damage. We compared, and you can also see, and since we also know the dimensions, we also did for other bridges. This is with a less quality of images, we were trying to figure out how detailed we can get. We also did on concrete railway bridge and also steel railway bridge. We were working on different materials and the number of images and the distance between drone and bridge and the kind of details which we can get from the this 3D reconstruction. Now, once that is done, the most important, as I said, from the first slide, is 10 different engineers have rated the same bridge in a 10 different ways and based only on visual inspection. Now, with this method, and here we also did damage quantification. Now we give input image and damage is detected, and you have instant segmentation, and then you can see this area per class. This is vegetation and water seepage, motor loss. For different images we have did here, so because here we have different ways. Now this all can be collaborated for one 3D reconstruction for one bridge. We can get total area of vegetation and how many places the vegetation is there. What is the total area of water seepage and at different locations of water seepage. All this can be accounted and this can be quantified. Now, once you have a 3D model and all the damages, visual damages are quantified, now the rating of the bridge could become uniform if it is done or if this methodology being used. So we don't have, because for any person to look at visual inspection and to quantify damage is very challenging. Now we can tell this damage is there, but what is the quantification of damage is very, very difficult to tell by a human perception. Even by experience also, sometimes it's very difficult. But this, the accuracy of this is also very higher. As I said, quantification is also almost like 95% and much higher. We can actually calculate the areas of all kinds of damages. And if we have 10 bridges and 10 different bridges, we can have the quantification of different damages on different bridges. And based on the rating or weightage, like cracks have higher impact on the bridges and its location, we can actually give the weightage to the crack and its location. And based on that, rating can be done. So our first objective when we started, we wanted a uniform rating, and now we are in the stage where we can rate uniformly got this page. And not only that, suppose if somebody someone is really interested to see the bridge or doing the inspection of the bridge while sitting at the office, we have also built virtual reality where a person can have this we can have this HoloLens and they can actually feel as if they are at the bridge. They can walk around the bridge and they can actually zoom in and zoom out and they can actually see that. So when a report is submitted to any of the Indian official or client, so they can actually look at the report damages and all, and they can also open 3D model in their office and actually they can validate whether all things have been actually recorded or not. So that is also done. So we also did virtual reality just by saying that do the inspection from where you sit, or we will bring the bridge to you to your location and you can inspect the bridge. That is also been done. This has also been done, and this is in our research center where we were trying to look at the one of the bridge which we have constructed in 3D. And not only that, suppose if we have a live video, and then this is processed, and this is processed, then it can also show you. Now these things have become little common. So you can see motor loss, vegetation, water seepage, and of course it is trying to give its confidence level. And this is left side is something which has real video, and this is a processed video, and it is highlighting the damages. And similarly, the other video where you have taken a video, and this is the drone shot. So drone was going very slowly, and then this is the actual video. You can see the pace of the drone, how the video is being taken, and the right side video is processed, and you can see different types of damages with different colors, with of course different confidence level. Now, from all this, one thing we were able to automatically were able to do the complete 3D reconstruction of the bridge, and by using YOLO, we were also able to classify the damage. We know the location of damage, and then we can also had an instance segmentation of damage, and we were also able to quantify the damage, and we will also know different types of damage on the bridge as well. So in short, I didn't want to get too much technical, but we will be very happy, very happy. And so what we did was we were trying to assess a bridge, and then we wanted to give a uniform rating to the bridges. So that is what we have achieved right now in this. So what is that is a key message of the presentation is, before inspection had a lot of challenges. A person was not able to travel to the bridges always. There has to be seasonal visits. Sometimes it was very challenging for the engineers to go to the bridge. So now inspection has become a data driven, and these inspections of the drones are repeatable, and it is also scalable too. And the second, the most important one is the accuracy of this damage classification, identification, quantification largely depends on how do we train our model, and it all depends on the kind of quality of data we get. So this is what we have transformed into. We have transformed ourselves into a data-driven assessment, and by using AI, we also have tried to make ourselves more of automation of assessment of bridges. The final takeaways from this presentation is you all have to understand that unmanned aerial vehicles and AI are not the replacement of engineers, for sure. They are just empowering them. Like if I am speaking on a mic, the mic will only make me that my voice is audible by hundreds of people. If I talk in a normal tone, only few of people can understand. So technology can always enhance human being capability or capacity. In the same way, UAVs and AIs will empower the kind of quality of inspection which we are trying to do, the first. And second, then it will also help us in rating the bridges uniformly. And this is what we have from this research which we've been doing from last 2 years, especially on UAVs and AI. This was in our research center. So we wanted to see how drone stability, how much they can fade and all. So I have also requested Mr. Mustafa and Revan Sagar also to be part of this presentation. In fact, even though I have presented, in fact, both of them have spent enormous amount of time at various bridges, had to travel early morning, 4 o'clock, 3 o'clock, sometimes they had to stay and they had to take images all over the day, sometimes early morning, late evening. And they have visited different bridges. In fact, all Jhansi bridges with the help of KDM engineers, both of them were taking most of the images of all these masonry bridges. So special thanks to them, and they are being part of that. Also, I have requested them to talk for a minute just after my presentation so that they could actually share the kind of challenges they had at the site. Sometimes it's easy to show images, to stand like this, like with these drones, but sometimes these drones can be very challenging at the sites. So this is the study which we did, and what we are trying to do is we are trying to make our bridges talk with sensors and with our drones. So maybe next time we'll also talk more about LLMs, where we have also reached to a stage where we are keeping sensors to the bridge, and anything happens on the bridge, then it is a voice-based understanding that bridges can talk to us. So we're working on that, and most probably for the next presentation seminar, we'll be very happy to provide that maybe in another 3 or 4 months. So just before I end, it was a very small presentation, I know, but I didn't want to have more of technical. I just wanted to show how things are being worked out and made easier for engineers and for a very quality assessment of the bridges. So special thanks to Mr. Engineer Kaushik Garu for giving me this opportunity from Qcrete company, and also Mr. Anil Garu, Anil sir from ICI Mangalore Center, the chairman of ICI. Special thanks to them. And also, I would like to also acknowledge a company, NVLN, which is the one of the first company where we have inspected around 900 bridges in between 2015, 16, 17, and 18. Without which we would not have gotten a lot of data. And Varshita was one company which helped us in understanding the assessments of bridges with NDT, and also to give repair and rehabilitation schemes. And KDM is one company where we've been working a lot from last 8 years, and especially all this automation and a lot of this RS analysis, sensor analysis were done by the company. Special thanks to that company as well. So every year we have this which is called SHM, which we do at Mahindra University. And if you can see, we have a collaboration with Kyoto University. We have some Israel company which is working on embedded sensors, and we have myself, Professor Profula, and we have also have collaboration with Infosys. And we have various people coming from all around the world to share the latest technologies in assessing infrastructure in India. So we'll also share other information if we are trying to have that. Since this is the actual team last time we had in 2025 for presenting similar things. A lot of people have come to our campus and experienced the virtual reality of bridges. They walked on the bridges, and they've also seen the condition assessment of the bridges here at the campus. And I would really thank for your patience. I know it is not that easier to attend a lecture at this point of time, because most of the people would be traveling from office to home, and it is not that easy. So thank you so much for your patience, and we are also happy to take any questions. Just before taking 1 or 2 questions, I just have my research students here. They would actually talk for a minute and 1 minute on what the challenges they had, because sometimes it's good to hear from themselves. So I request Mustafa and Sagar to tell any challenge they had at the site. Yes, go on.
Hello, myself Revan Sagar. I'm a research assistant from Center for Sustainable Infrastructure and Systems, and I am working on this drone-based automated damage detections and 3D reconstruction of bridges. Uh, Actually, in the manual inspections, we are facing like there are so much large structures. So we are continuously working on UAV based for reducing the time, nearly 50% of reduction in time in field work. And there are completely in manual inspection, there will be covering only like 50 to 60% of the complete pitch, and drones will be helpful for covering 100% of the structure without leaving any corners. So we are trying to incorporate drones into our manual inspection so that the inspection will be so easy and helpful.
Unmute. Yeah, Mustafa, you can tell because Mustafa was the AI engineer. We'll come back to questions in a minute. Yes, Mustafa, you can tell.
Good evening, everyone. I am Ahmad Mustafa Ahmed. I was the person who was working on the computer vision for structural health monitoring, and traditionally engineers inspect the structures using manual inspections, which is time consuming, and it is having a lot of challenges like hard to reach areas and everything. So the objective of my work was to create a model instead of manually reviewing or taking images and reviewing each image. The model will automatically detect the damages, quantify the damages, and also give the area of the damages. So the main important thing for that is the quality of the data and the training of that model. So that is what I want to say from my side.
Okay. Yeah, thank you, Mustafa and Revan Sagar. So thank you again for your patience. Now we are okay for taking some questions. So just before that, I would also tell another thing that now if anyone as a civil engineer who is done with bachelor's or master's who are interested to be part of this work, you're welcome. You can message to Qcrete, or you can also message to us. We'll be happy to have you on board, especially who are interested in doing some kind of work, some civil or electronics background. So thank you once again. So we will take some questions. If anybody has got questions, I think I can see a few questions. Yeah, is my voice audible now? Can anybody confirm?
Yes, sir, audible. Yes, sir, audible.
Okay, so I'll take these questions. Okay, I have few questions here online. Yeah, one question from my end. Is this research is submitted to Indian government for repairing? As a civil engineer, we are the most responsible for the people. Yes, thank you. Yes, this research methodology has been presented to Indian government. In fact, we are getting fund from Indian government, especially for Indian Railways. Now the same has also been present to MPRDC, Madhya Pradesh Road Development Corporation also. They are also trying to assess few hundreds of bridges using similar kind of a technology. So now from this month end, our research team is planning to do almost like around 50 to 100 bridges and their ranking. Most probably it would take one, maybe 6 months more to finish all that aspect of 3D reconstruction, damage classification and quantification, and also automatic rating. And once that is done, I think we would be able to develop our own tool where you just have to upload the data and it will give you the ranking. That is first. And second is any bridges repaired images or dismantled pics. I have not kept all the images. Yes, we have not did this study for the already dismantled bridge, but for any bridges, like we've recently visited Tamil Nadu at the coastal area, we've taken a lot of images, and we were also trying on that one as well. So currently we are not distinguish between repair and non-repair, but we are only distinguishing or classifying the different types of damages. And most probably if we have more data next time, maybe in our study, we'll also be able to tell whether the bridge has been repaired in the past or not. Like when a human being sees, he tells that, okay, this bridge has been repaired. Similarly, we might be able to develop that as well. So there is one more thing, sir. I just want to know more about the distance between camera, drone, and the bridge for data collection purposes. Yeah, the more important is, I think, in 3 meters. So I was just asking Revan sir. So he has been worked with 3 meters, 4 meters, and 1 meter as well. But we just have to make sure if our drones are autonomously can identify the obstacle, then they maintain their own distance. But if our obstacles are little higher, trees are grown much higher, then we make it from 4 or 5 meters. But more important is when we take image from a 1 meter, 2 meter distance, we can also measure a crack which is less than 1 mm also. Because when a camera is nearer, your accuracy of very minor damages is very, very high. So if you are starting, you can start with around 2 or 3 meters, but still we should be able to get a lot of data. And if you are able to do DSLR, it can be much farther away. But it is very challenging to fit DSLR camera to the drone. Yeah, which fusion technique or tools are used to the LiDAR and RGB data? Currently, we used a software, and we also have our own program on that one. So one which is easier, everyone can do is AJSoft and Pix3D is two softwares. You can actually try on that one for fusing all the images. And another thing, as you have asked, when you have a LiDAR data and image data, that can also be used even in AJSoft as well. So now you can directly use that, because LiDAR can also get the texture of the image, texture from the image, so that can be mapped in the tool. So okay, this is already mentioned. What was the distance maintained between drone and the bridge surface inspection? You can have 2 meters, 3 meters, but if it's 1 meter, then you'll get a lot of details. Is there any drone which is available for buying in India for bridge inspection? Yes, there are a lot of companies, 2 or 3 companies. We had ourselves a lot of challenging to get a drone, but yes, there are some companies now. Especially from last 2-3 years, a lot of manufacturing companies have come up in India, and then you can actually contact them. If Revan Sagar can tell anything on that. Revan Sagar is actually trained pilot of the drones, which who have talked previously. Can you suggest any companies' names? Okay, so he says about Garuda Aerospace, and there are some companies in Bangalore as well, very good companies like Xboom. Is other companies which have the selling of these drones. They can sell from made or also imported drones as well. So which tool you are using for annotation of cracks and other abnormalities? So Mustafa actually has used Label Me and RoboFlow are a couple of tools which they have used for annotating all the damages. Label Me and RoboFlow. Thanks. Do you have any open source data set available based on your inspection? Yes, accidentally now we have lot of open source Google data and other sources. Kaggle is another space where you can have open data sources which you might use for the similar kinds of a study. We have spent a lot of time in getting all the data, but right now there's a lot of like you have Harvard and MIT and the University of Illinois. There are some of the universities which have kept open source data of all different types of damages which they have taken in their countries. But similar things can be used even for our data as well. You have open source data sets. Okay. What is the methodology and data interpretation for bridge? What is the methodology and data interpretation for the bridge inspection and time involved? Okay, currently when we are inspecting any bridge, previously we took a lot of time, but this inspection, I think our team has taken around 3 hours to take all the images and coming back to the research center and building 3D and training. Maybe in 1 week, we can give all the information about the bridge based on the visual inspection. Complete. It can be given as a 2D plan, 2D elevation, all the geometrical details and different types, classification of damages and quantification of the damages, irrespective of whatever bridge it is. But when you have a bridge which is very, very large, like 2.5 kilometer, 3 kilometer, when we do the rendering part, when we 3D reconstruct it, sometimes it might take a little longer than 1 week, but otherwise all small bridges till 300 meters or 400 meters can be done within 3 or 4 days. Now, since our models are already trained, everything is done, we are trying to get down our time of complete assessment report. Even we are also able to generate complete automatic report as well using LLMs. So it might take around 3 days. So I'm keen interest in bridge analysis. How can I join? We are not a firm. We are a research center at Mahindra University in Hyderabad. I am associate professor here. So it can always, anybody who's interested can drop a message and be part of our team for 6 months to 1 year. and learn, and you can have your own assessment by yourself. So are you doing any continuous monitoring of bridge at present? Yes, of course. Continuous monitoring right now we're not doing for 4 or 5 years, but 1 month monitoring or 2 months monitoring are being done. But that is in collaboration with the company, not by Mahindra University by itself. That is in collaboration with the company. Yes, we are doing it. But accidentally, I will not be able to give details online. But other details, personally message, yes, of course, we can share some details. And maybe somebody is interested, they can also visit the site as well. So I think those were the questions. And if I'll just have, so this is my email ID. If somebody is interested, they can actually drop us. Once again, I have kept my presented wantedly very small because we didn't want to get into too much technical, but wanted to tell the power of UAVs and AI in enhancing human being inspections to much qualitative and much more quantitative as well. So thank you so much once again for Better India. Once again, thank you ICI Chapter Mangalore and Qcrete Concrete for organizing this. And special thanks to Kanesh from Qcrete, who has actually helped me joining 2 days before and rechecked, and he was following me about the quality of presentation, quality of mic, video and all. Special thanks to him as well. So thank you once again, and thanks from my team side also. So from Mustafa and Revan Sagar, we thank you all for questions and appreciating our presentation. Thank you once again. But small quote, I always wanted to tell to everyone, you might be a small person in this world, but you might be a whole world to one person. Travel safe back to your homes. You might be a small person in this world, but you might be a whole world to one person for your family. So travel safe. And second, if you want something you never had, then do something you never did. If you want something you never had, do something you never did. With this, thank you so much once again. Thank you all. Have a great evening. Thank you.
Thank you.
Good evening.
Yeah.
On behalf of Qcrete Readymix, we are thankful to Dr. Dilip Garu for this wonderful lecture. This is, in fact, his third lecture, and it is number 66 on Qcrete platform. And we also thank ICA Center Mangalore and Mr. Anil Baliga and MD of our company, Mr. Shelly Fernandez. As the world is moving more on towards AI and associated techs, Dr. Dilip has delivered a wonderful informative lecture, especially for the people who are interested in working on repair and rehabilitation sector in India. So we are really thankful to you, sir.
Thank you.
Once again, with all our team, we are thanking you for this wonderful presentation, crisp and beautiful, moving towards new age. And we will love to have you again with more information and more subjects leading towards the modern age technologies like AI, something like that. Thanks a lot.
Thank you. Thanks. Thank you.
Yeah. And I also thank the audience who have gathered here to listen to this wonderful lecture from Dr. Dilip Garu on this Friday evening. And I also thank all our associates and our staff for helping us to do this. Thank you. Thank you, sir.
Yeah, thank you all once again. Have a great evening. Thank you, sir.
Thank you. Namaste.